Hi, welcome back to Missing Chemistry. This is a Scientific Method Explored lesson. All right, when I think about the scientific method is a process on discovering things, okay? And we actually use the scientific method every single day in our lives. Now, well, which scientific method are we using? Are we using the 3-step scientific method, the 5-step scientific method, the 7-step scientific method, the 11-step scientific method, or some people out there actually believe that there's no such thing as a scientific method, but I really disagree with that. All right, well, first of all, we're going to start right here, okay? So let's circle that. And what you're going to do in any type of scientific method that you use, you have to make an observation. An observation, you're observing something. You're observing a phenomenon, something you see in nature, and you're trying to think about why that is occurring. Then you make a hypothesis. A hypothesis is a I think or a belief statement. And you think or you believe if you do this and this and this should occur. Then you design an experiment or procedure, and then you do that experiment. Well, if the experiment doesn't work out and prove your hypothesis, then what you do is you can redo that same hypothesis and test the experiment again to see if you're going to get the same results. And if it doesn't work out again, then what you're going to do is you're going to come back up this slide here, and you're going to redo your observation, okay? Now, let's say, for example, it works. Let's say the experiment does work, and your hypothesis is true. And let's say it's not true just one time, but it's true every time you do it. Then you create something called a law. Now, a law, or a natural law as it's called, is true every single time. Okay? Some people start here and then they go and they make a theory. A theory is like a hypothesis. It's something you believe to be true, and you're basing it upon some knowledge that you have. You make a prediction. You design an experiment. Okay? And if the experiment works, your theory is true. But if your experiment doesn't work, you can modify your theory, make a new prediction, okay? And then try the experiment again. And if it works, your theory is proven true. And if the theory comes to be true every single time, then it'll become a natural law. Now, in the 5-step scientific method, you have a problem, you have a hypothesis, a procedure or experiment, you collect data, and you make conclusions. And again, that all depends upon, hey, did it work out? Did your hypothesis, was it successful? Well, then you have to look at that over and over and over until you see that it does work. You may have to redesign your procedure. You may have to redesign your experiment if you don't want to change your hypothesis. But then again, data and conclusions determine whether your hypothesis is correct or not. Now, there are other things that can affect an experiment. Something called the independent variable is controlled by the experimenter. The dependent variable changes in response to the independent variable. So as things change, that dependent variable will change to the response of the independent variable placed upon it. Some other things you might want to consider when using the scientific method are extensive properties and intensive properties. Extensive properties depend upon the amount of matter. An example that would be mass, volume, and length. Okay? And intensive properties do not depend upon the amount of matter, which would be like color, freezing, melting, boiling points, and pressure. So whether you believe in the 3-step, the 5-step, the 7-step, or 11-step method, the scientific method is an excellent way to explore problems in nature. Well, you guys be snarly, and we'll see you back here at Missing Chemistry!